Thank you, Chair. And I also like thank the organizing committee for having me here. Today, I would like to share what I've been thinking about for years, especially after the Fukushima accident with you. Let me begin with the current situation in Fukushima, how is the radiation level, and how is the people's concern in Fukushima. And one of the causes of the concern, the impact of the Fukushima accident on the environmental biota, I will review that. In addition to that, I would add how the investigation has been extended, and also through this investigation, I would like to touch with the similarity and differences of the protection system, of the protection of people and the environment. And especially one of the striking features for these the protection system seems to me the dose and dose rate. I will come back later soon. And finally, let me summarize my talk at the end. And this is the 6.5 years after the accident, the radioactivity level, due to the radionuclides, released by the Fukushima Daiichi NPP accident has decreased. So, and according to the decrease, so yes, in many areas, the evacuation orders have been lifted. However, the people still are much concerned about the more elevated level of radiation than before. And this is illustrated by the fact that in the weather report on TV, so here is just a temperature distribution. In addition to the temperature distribution, they report a radioactivity measurement, measurement distribution too. This is the good indication that they still concerned about the elevated radiation level, that is the existing exposure situation. And not only the elevated level of radiation level, another the causes of concern was the impact of the environmental biota. Relatively soon after the accident, there was the abnormality was reported. One for the blue grass butterfly, and another example was the Japanese fir tree. So for the butterfly, they found the change in the shape and color of the wings of the creature. And for the Japanese fir tree, there was a loss of the leader shoot, the growing tip, part, which is very important for the plant. They are continuing to investigate and they are they are trying to check the reproducibility of their result. And for the butterflies, so they are doing the experimental work. In addition to collection of the more samples, they are doing a experimental work, both external exposure as well as internal exposure. And they claimed the abnormalities were caused by radiation. And but there is some points to be discussed. One of them is the sensitivity is very high, based on their calculation. So the effect is found at very, very low dose range, low dose rate range. That should be discussed in more detail. And of course, the mechanism how the abnormality was created is still to be elucidated. On the other hand, using the same butterfly species, there is another report in which they are checked again using the experimental work, and they claim that the abnormalities were caused not by the radiation, but by some other agent. For example, the fine the particulate matters, or something like that. So anyway, we have to wait a little bit more to identify whether the abnormality was caused by radiation or not. As for the fir trees, the same group continues to check the reproducibility, that using a experimental radiation gamma irradiation facilities and the gamma field. And excuse me, very busy slide. But in the middle, you can see the dose rate they are using. The ranging 1 milligram per day to tens of milligrams per day for the case of gamma field. And just over the picture in the middle, you will see the 1.3 years on the left and 2 years on the right, indicating how long it would take to reproduce the event in the tree. But I really appreciate them to using the experimental conditions to bridge the field observation and the experimental work. Yeah, probably for the investigation of the effect on the environmental biota, this kind of approach should be necessary. And for the protection of the environment, protection of the non-human biota, so one of the key the concept was already explained by Kathy. So reference animals and plants. So reference animals and plants are a kind of example of the wide variety of the creatures which covers the wide variety of the biological features, as well as covers a wide variety of the living situations, conditions. And they are introduced, they are used for the purpose of the relating exposure to dose and dose to effects. So let me repeat. The reference animals and plants, RAP, are used to a good example of the effect of the radiation on the environmental biotopes. The important concept is again Cassie already explained. The DCRL derived the consideration, the reference levels. Yeah, this is a band of dose rate, within which there is likely to be a deleterious effect. Yeah, for individual RAP. Here is a list of the RAP and DCRL, along with the lifespan of the creatures. So the highlighted in different colors. So the most yellowish the area is the most resistant type of the creatures. And then the less yellowish, less tolerant. So, and the most sensitive creatures has a DCRL of 0.1 to 1 milligram per day. And this concept was introduced in the parallel pathways as you see on the left. So, and for the protection system of people. And in the people, for the people's protection, so those in order to estimate dose and estimate the effect, the reference male and reference female are introduced. In parallel way, so the reference animals and plants are introduced for the protection of the environment. However, I see actually here is a parallel pathway. Yeah. However, I see some difference. That is, so for the people, they use dose. For example, those criteria are given in dose. For dose limits, dose constraints, and the reference levels. On the other hand, for the protection of the environment, for the non-human biota, so dose rate is used for those criteria, as you saw as a DCRL. And for the dose and dose rate, to analyze the effect of dose and dose rate, in other words, dose dependency and dose rate dependency, we have developed and used this kind of chart. We call it a dose and dose rate map. In this chart, dose rate is plotted along the x-axis, and the total dose is plotted on y-axis. And here in this figure, I put two very typical exposure exposure condition. That is, first one is A bomb, the pretty high dose rate, and a wide range. It covers wide range of the total dose. And on your left, you see the high natural background radiation situations. So very low dose rate. And when you live there for 50 years, for example, there is an accumulation of that dose, as you see on your left. And if you superimpose the DCRL here, it looks like this. And here, so for the small a, this is for the pine tree, because pine tree, the lifespan of pine tree is 200 years. So it range pretty long on the vertical square. And then as you see, by analyzing the effect on this map, you can find you have enough data, enough information, and but in different way to say, so in which conditions you are lacking, you need more information. You can use this kind of analysis on this dose and dose rate map. And let me ask one question: is dose rate is good enough to evaluate the impact of radiation exposure on certain biota, certain environmental creature? Actually 3 months after the Fukushima accident, we found a very high level of radiation in Okuma town, near the nuclear power station, nuclear power plant. So, and it is 20 times, nearly up to 20 times as high as a benchmark. This in this table, the benchmark was taken as a lower end of DCLL. So, and you see, so in many number of cases, there is the dose rate was more than the DCRL. Yeah. However, this case is very, very special because after the accident, there was a transient, in other words, dynamic change of the dose rate, something like this. So, and after the accident, dose rate came up, and then reached a peak, then gradually went down. So, and the high dose rate shown in the previous slide should be taken as one point of this time course, dynamic change of the dose rate. So, and probably to evaluate the actual impact of the radioactivity on our environmental creature, you need to multiply the dose rate at each timing with multiply by the Okay. All right. So multiply by the duration duration of the dose rate. Yeah. Why don't we look back again for the Fukushima accident. After the Fukushima accident, we calculate the dose to the evacuee in this way. So there was a data, temporal change data of each point. So how was the dose rate? And we asked the evacuees where you were for how long. So by calculation, the dose was assessed for the evacuees. And then let me so far I've concentrated on the dose and dose rate difference. However, the already shown there is another differences. That is, for the environmental protection, the aim is the maintenance of biological diversity and the conservation of the species. That is, the object is a species, in other words, population. This is good. This is a good contrast to for the people. The object is the individual. So let me summarize in this way. Although the system of the environmental protection has been evolved in parallel way to that of the people, however, there are some differences. One of them is the dose and dose rate. The other is object or target of the target of the protection. So toward the integration of the protection system, so we need to take the difference rather than the similarities into consideration for the people and the environment. Thank you very much for your attention.